Let us learn three-dimensional geometry, chapter 11. Let us take the coordinate axes. Let this be y-axis, z-axis, this be x-axis. Let us consider a directed line segment passing through the origin L, which makes angles alpha, beta, gamma with the positive direction of coordinate axes. So alpha, beta, gamma are the direction angles. And we know that cos alpha, cos beta, cos gamma are the direction cosines of that directed line segment. Let this be x-axis and let us consider a line passing through the origin which makes angle alpha with the positive direction of x-axis, say. Then this angle with the negative direction of x-axis, it makes an angle pi minus alpha. Now let us extend this line. Line can be extended in both the directions. We have two sets of direction angles. One set is alpha, beta, gamma. The other one is pi minus alpha, pi minus beta and pi minus gamma. Therefore, we have two sets of direction cosines. One is cos alpha, cos beta, cos gamma, and the other one is cos of pi minus alpha, cos of pi minus beta and cos of pi minus gamma. These are also direction cosines of the same line. Therefore, DCs of a line are plus or minus cos alpha, plus or minus cos beta and plus or minus cos gamma. And we denote the direction cosines by the letters L, M and N. And we know the relation between L, M, N. L square plus M square plus N square is 1. Now, if the direction cosines are L, M, N, any three numbers proportional to the direction cosines are called the direction ratios. So, to find the direction ratios, multiply these direction cosines by any non-zero real constant. Therefore, KL, KM, KN will be the direction ratios of that line where K is not equal to 0. Therefore, for a line we have two sets of direction cosines and infinitely many sets of direction ratios. Whereas a vector has only one direction, therefore it has only one set of DCs and one set of DRs. If direction ratios are given, say A, B, C, how to find the direction cosines? Just divide by the magnitude root of A square plus B square plus C square. B divided by root of A square plus B square plus C square and C divided by root of A square plus B square plus C square. Because it is a line, we have both the directions, we can take plus or minus sign. Therefore, we have two sets of direction cosines for a line. So, this is an important formula given the direction ratios to find the direction cosines. Now, let us see how to find the direction ratios and direction cosines if 2 points on a line are given. Let us consider this line and 2 points P and Q on this line are given, say let P be x1, y1, z1 and Q be x2, y2 and z2. We know how to find vector PQ or vector QP also we can find. It is position vector of the terminal point minus position vector of the initial point, which is x2 minus x1 I cap plus y2 minus y1 j cap and plus z2 minus z1 k cap. Or we may find QP vector. Therefore, DRs of this line are x2 minus x1, y2 minus y1, z2 minus z1, or we can take it as x1 minus x2, y1 minus y2 and z1 minus z2. Remember, for a vector we have only one set of direction ratios, terminal point minus initial point. So if 2 points are given on a line, this is how we find the direction ratios. Now let us see how to find the direction cosines. So to find direction cosines, we have to divide by the magnitude. So x2 minus x1 divided by r, y2 minus y1 divided by r, and z2 minus z1 divided by r. And because it is a line, we can have plus or minus sign, where r is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. So these are the direction cosines. Now we know how to find the direction ratios and direction cosines when the angles are given or when 2 points on a line are given. Let us do exercise 11.1. This is an easy exercise. First question. If a line makes angles 90 degrees, 135 degrees, 45 degrees with x, y, z axes respectively, find its direction cosines. So alpha, beta, gamma are given. Alpha is 90 degrees, beta is 135 degrees and gamma is 45 degrees. When the angles are given, we know how to find the direction cosines. DCs are cos alpha, cos beta, cos gamma. And because it is a line, we have two sets of answers. We can have plus or minus sign. Plus or minus cos 90, plus or minus cos of 135 degrees. 135 degrees, I can write it as 90 plus 45 degrees and plus or minus cos 45 degrees. Therefore, the answers are cos 90 is 0, cos of 90 plus theta. 90 plus theta is second quadrant. In the second quadrant, cos is negative, and for 90 we change the ratio. Minus sin theta is the answer. Therefore, it becomes minus sin 45, which is minus 1 by root 2. And then cos 45 is 1 by root 2. Therefore, the answers are 0, minus plus 1 by root 2 and plus or minus 1 by root 2. Here we need not write plus or minus sign for 0. This is the answer. Now question number 2. Find the direction cosines of a line which makes equal angles with the coordinate axes. So it is given in the question that alpha, beta, gamma are equal. Therefore, cos alpha, cos beta, cos gamma are also equal. And we know the relation between L and N. L square plus M square plus N square is 1. Therefore, cos square alpha plus cos square beta plus cos square gamma is 1. All three are equal. So I can write it as 3 times cos square alpha is equal to 1. Cos square alpha is 1 over 3. Therefore, cos alpha is plus or minus 1 divided by root 3. Therefore, the direction cosines of the given line are plus or minus 1 by root 3, plus or minus 1 by root 3 and plus or minus 1 by root 3. Because we are writing the direction cosines of a line, we are writing two sets of answers. Let us do question number 3. If a line has direction ratios, DRs are given, which are minus 18, 12 and minus 4. What are its direction cosines? Let us find the magnitude R, which is equal to root of minus 18 square plus 12 square and minus 4 square, which will be equal to plus 4 square. Eighteen square is 324, 12 square is 144 and 4 square is 16. We get root of 484. Square root of 484 is 22. Therefore, the DCs are minus 18 over 22 12 over 22 and minus 4 over 22. Let us simplify and write these answers. We get minus 9 over 11 and 6 over 11 minus 2 over 11. Since it is a line, we can write another set of direction ratios: plus 9 by 11, minus 6 by 11 and plus 2 by 11. Question 4. Show that the points, 3 points are given, 2, 3, 4, minus 1, minus 2, 1, 5, 8, 7 are collinear. Collinear points means lying on the same line. Let us name them as A, B, C. If 3 points are collinear, drs of AB and drs of BC should be proportional. Let us find drs of AB. When 2 points are given, we know how to find drs. Just do subtraction. In any direction you may subtract. You can do B point minus A point or A minus B. I am doing B minus A. So minus 1 minus 2 is minus 3. Minus 2 minus 3 is minus 5. 1 minus 4 is minus 3. Similarly, let us find drs of BC. Or you may find drs of AC also. I am doing C minus B. 5 minus of minus 1 plus 1, which gives us 6. 8 minus of minus 2 plus 2, 10. And 7 minus 1 is 6. Now check for the proportionality. Minus 3 over 6 is equal to minus 5 over 10 is equal to minus 3 over 6. All three ratios are same. Therefore, I can say that AB is parallel to BC. But B is a common point, which implies the points A, B, C are collinear. Question number 5. Find the direction cosines of the sides of the triangle whose vertices are. Let this be the triangle. Let us take the first point as A, which is 3, 5, minus 4. Let the second point be B, minus 1, 1, 2. And third point be C, minus 5, and minus 2. Let us first find drs of direction ratios of the side AB. To find drs, we need to subtract. We may do B minus A or A minus B. Let's do B minus A. Minus 1 minus 3 is minus 4. 1 minus 5 is minus 4. 2 minus of minus 4 plus 4, therefore 6. To find DCs of AB, we need to divide by the magnitude. Let us find the magnitude of this. Root of 4 square plus 4 square plus 6 square, which is root 68. Root 68 can be simplified. Let us do prime factorization. It can be written as 2 times root 17. Therefore, DCs of AB are minus 4 divided by 2 root 17, comma minus 4 divided by 2 root 17 and 6 divided by 2 root 17. We can simplify these answers. 2 could be cancelled. So minus 2 over root 17 and minus 2 over root 17 and 3 over root 17. And we can write another set of answer. 2 divided by root 17 plus 2 divided by root 17 or minus 3 divided by root 17. Similarly, let us find drs of BC. We may do C minus B or B minus C. Let us do C minus B. Minus 5 plus 1, which is minus 4. Minus 5 minus 1 is minus 6. Minus 2 becomes minus 4. We have the same numbers 4, 4 and 6. We will get 2 root 17. Let us write DCs of BC. Minus 4 over 2 root 17 minus 6 over 2 root 17 and minus 4 over 2 root 17. Let us simplify and write the answers. Minus 2 divided by root 17 minus 3 divided by root 17 and minus 2 divided by root 17, and we can write another set of answer. Just change the sign and write plus 2 divided by root 17, 3 divided by root 17 and 2 divided by root 17. Now let us find DRs of AC, or you may write CA also. Let's do C minus A. Minus 5 minus 3 is minus 8. Minus 5 minus 5 is minus 10. Minus 2 plus 4 is 2. We need to find the magnitude. Square root of 8 square plus 10 square plus 2 square. So it is root of 168. Let us do prime factorization of 168. 242, again 221, 3 and 7. Therefore, this is 2 times root of 42. Let us divide. Minus 8 divided by 2 root 42, minus 10 divided by 2 root 42 and 2 divided by 2 root 42. Let us simplify these numbers. Therefore, we get the answers minus 4 divided by root of 42, minus 5 divided by root 42 and 1 divided by root 42, or we can write another set of answer by changing the sign. Plus 4 divided by root 42 plus 5 divided by root 42 and minus 1 divided by root 42. Now let us learn how to find the equation of a straight line in three-dimensional geometry. The first one, let us write the equation of a line when a point on a line and the direction of the line are given. Let L be the line whose equation we are going to find, and a parallel vector B is given, say. Let A be a point on this line whose position vector is vector A, and P be an arbitrary point whose position vector is vector R. So vector A and vector B are given, say, where A is the position vector of a point on the line and B is the parallel vector which gives the direction of the line. From the figure we can say that vector AP is parallel to vector B and vector AP is terminal point minus initial point, R minus A. This is R minus A. R minus A is parallel to vector B. If two vectors are parallel, we know that one can be written as a scalar product of the other. Therefore, vector R is equal to vector A plus lambda times vector B. And this is the vector equation of this straight line when you know one point and the direction. So in this whole lesson we will be learning vector equation and Cartesian equation simultaneously. Let us find the Cartesian equation of this straight line. See the figure. Let us take the coordinates of A point as x1, y1, z1. The parallel vector vector B as AI plus BJ plus CK. And coordinates of the arbitrary point P as x, y, z. So we are taking P point as x, y, z, and A point as x1, y1, z1, and vector B as ai cap plus bj cap plus ck cap. Let us substitute these vectors. So our vector is xi plus yj plus zk, and A vector is x1i plus y1j plus z1k, plus lambda times B vector is ai cap plus bj cap plus ck cap. Let us equate the I, j, k components. X is x1 plus lambda times A, and y is y1 plus lambda times B, and z is z1 plus lambda times C. And these are called parametric equations of a line. Now we can find lambda from all the three equations. So lambda from the first equation is x minus x1 divided by A, and lambda from the second equation is y minus y1 divided by B, and lambda from the third equation is z minus z1 divided by C. This is the Cartesian equation of a straight line in three-dimensional geometry. The denominators are the direction ratios of the line or of parallel vector, we can say. Therefore, in place of direction ratios, we may use direction cosines too. Therefore, the equation can be written as x minus x1 divided by L equals y minus y1 divided by M equals z minus z1 divided by N, where L, M, N are direction cosines. These are the vector and the Cartesian equations of a straight line when you know one point on the line and the direction of the line. Now the second case, let us see how to find the equation of a line when 2 points on the line are given. Now let us consider a line. Points A and B are given. Let us take position vector of point A as vector A and position vector of point B as vector B. Take an arbitrary point P on this line whose position vector is vector R. Now A, P, B points are collinear. We know the collinearity condition of 3 points. Vector AP is parallel to vector AB. If two vectors are parallel, we know that one can be written as a scalar multiple of the other. Vector AP is position vector of the terminal point minus position vector of the initial point, which is equal to lambda times vector AB will be position vector of the terminal point minus position vector of the initial point. Therefore, vector R is equal to vector A plus lambda times vector B minus vector A. This is the vector equation of a straight line passing through two given points. Here lambda can take any real value. Let us derive the Cartesian equation of a straight line. We will take vector R as xi cap plus yj cap plus zk cap, and vector A, which is the position vector of the given point A, as x1 I cap plus y1 j cap plus z1 k cap. If points are given, we always write in terms of x, y, z, and if directions are given, we write them in terms of a, b, c. And let the position vector of the point B be vector B, which is x2 I cap plus y2 j cap plus z2 k cap. In this case, vector B is a point on the line, whereas in the previous case, vector B was a vector parallel to the line. A, P, B are collinear points. Therefore, we know that dRs of AP proportional to dRs of AB. dRs of AP are, we will do P minus A, X minus X1, Y minus Y1, Z minus Z1, and they are proportional to dRs of AB. Let us do B minus A, X2 minus X1 equal to Y2 minus Y1, and here Z2 minus Z1. This is the 2-point form of a straight line. In 11th standard, we had 2-point form of a straight line. In 2D, we had this equation without the z coordinates. See the denominators, they are the dRs of the straight line. Now let us see how to find angle between two lines. Let us consider these two lines, L1 and L2. Let theta be the angle between them. To find the angle between these two straight lines, we can find the angle between their parallel vectors. Let the equation of the first line L1 be vector r is equal to vector a1 plus lambda times vector v1, and equation of the line L2 be vector r is equal to vector a2 plus mu times vector b2. Vector b1 is a vector parallel to the first line. This is vector b1, and vector b2 is parallel to the second line. To find the angle between the given two lines L1 and L2, we can find the angle between these two parallel vectors, vector b1 and b2, which are parallel to the given lines. Corresponding angles will be equal. Therefore, cos theta is equal to vector b1 dot vector b2 divided by magnitude of vector b1 times magnitude of vector b2. If you see angle between two lines, one is theta, we have two answers. The other one is pi minus theta. Both are correct. But usually when they ask the angle between two lines, we give the acute angle as the answer. Therefore, to get the acute angle as the answer, we take the absolute value sign here to make the quantity positive. If cos theta value is positive, theta will be in the first quadrant, which is an acute angle. And if cos theta value is negative, theta will be an obtuse angle, second quadrant angle. And you should remember that cos theta angle between two vectors, vector A dot vector B by magnitude of vector A into magnitude of vector B, doesn't have absolute value sign, because angle between two vectors we have only one answer. We don't have pi minus theta, the other answer. Okay, therefore we don't have absolute value sign for angle between two vectors, whereas angle between two lines we have two answers. So we change the answer to positive value so that we get an acute angle between the two lines. Let us take vector b1 as a1 I cap plus b1 j cap and plus c1 k cap, and vector b2 as a2 I cap plus b2 j cap and plus c2 k cap. Don't get confused with this b2 vector and the component b2, it doesn't matter. Let us find the dot product. We multiply the corresponding components of ijk. You should not write ijk in dot product, it is a scalar quantity. Therefore, we get a1 a2 plus b1 b2 plus c1 c2. An absolute value sign to make our answer positive, so that we will give acute angle between the two lines, divided by magnitude of the first vector root of a1 square plus b1 square plus c1 square, magnitude of the second vector root of a2 square plus b2 square plus c2 square. This formula is in vector form and this formula is in Cartesian form. These are the formulae to find the angle between two lines. Let us consider the direction ratios of a line. Let it be L1. Let the direction ratios be A1, B1, C1. And direction ratios of the second line L2 be A2, B2, C2. If these two lines are perpendicular, then dot product has to be 0. Components of B1 be A1, B1, C1 and components of B2 vector be A2, B2, C2. The perpendicularity condition is vector B1 dot vector B2 should be 0. The dot product is A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Second point, when two lines are parallel, then vector B1 is parallel to vector B2. The parallel condition for two vectors is proportionality. A1 by A2 equal to B1 by B2 equal to C1 by C2. Or the other condition is vector B1 cross vector B2 should be 0. But we use the proportionality while solving the questions because it is easier, no calculation required there. We will see the different types of lines in 3D. The first one is intersecting lines. Shortest distance between them will be 0. These lines are coplanar lines as we can draw a plane passing through these two. And then the second type is parallel lines. We can measure the distance between parallel lines. Wherever we measure, the distance will be the same. And these lines are also coplanar. We will be able to draw a plane passing through two parallel lines. And the third type of lines, they are called skew lines. They are neither parallel nor intersecting. So such lines are called skew lines. Let us consider this figure and consider this as a room, that blue room, and D, E, F, G is the ceiling of that room. I am drawing a diagonal GE. So this is a line drawn on the ceiling of the room. Now consider the wall of the room OADG. I am drawing the diagonal of that wall DO. So these two lines never intersect each other and they are not parallel also. So such lines are called skew lines. And two skew lines are non-coplanar lines. We cannot draw a plane passing through two skew lines. Now let us see how to find the shortest distance between two skew lines. Let's consider two skew lines. I have drawn two skew lines in a two-dimensional board. So they look like intersecting lines, but consider them as skew lines. Let this be the shortest distance between the two lines. The line of shortest distance will be perpendicular to both the lines. Let us consider these two line equations as vector r is equal to vector a1 plus lambda times vector b1, and equation of the second line as vector r is equal to vector a2 plus mu vector b2. A be a point on the first line whose position vector is vector a1. B is a point on the second line whose position vector is a2. So this vector AB represents vector a2 minus vector a1, and b1 is a vector along the first line, b2 is a vector along the second line. So b1 cross b2 will be perpendicular to both b1 and b2. Therefore, we can take b1 cross b2 along the line of shortest distance. AM and BL are perpendiculars drawn on the line LM. So LM is the shortest distance, which is the projection of A2 minus A1 on B1 cross B2. And projection formula we know. Projection of vector A on vector B is A dot B by magnitude of B. Therefore, projection of vector A2 minus vector A1 on vector B1 cross B2. That gives you the shortest distance, which is length LM in the figure. D is equal to vector A2 minus vector A1 dot vector B1 cross vector B2 divided by magnitude of B1 cross B2. And distance should be a positive quantity, so absolute value sign should be written. This is the formula to calculate the shortest distance between two skew lines. Now let us see the formula to find the distance between two parallel lines. We cannot use the previous formula because for parallel lines B1 cross B2 will be 0. Consider these two parallel lines. Distance between them will be the same everywhere. Let us consider these two equations of these two parallel lines. Let A1 be the position vector of a point on the first line and A2 be the position vector of a point on the second line. Join these 2 points and complete the triangle TPS and let this angle be theta. Vector ST will be vector A2 minus vector A1. As the lines are parallel, vector B1 will be parallel to vector B2. They are proportional. Therefore, let us take vector B as either vector B1 or vector B2. We know sin theta formula using cross product. So, sin theta is equal to magnitude of vector B cross ST vector divided by magnitude of vector B times magnitude of vector ST. And sin theta from that right triangle TPS is opposite by hypotenuse d by st is equal to magnitude of vector B cross vector ST divided by magnitude of vector B times magnitude of ST. Now magnitude of ST can be cancelled on both sides. Therefore, D is equal to magnitude of vector B cross vector ST is A2 minus A1 divided by magnitude of vector B. And this is the formula to find the distance between two parallel lines. Be thorough with all these formulae. Let us start exercise 11.2. Question number 1. Show that the three lines with direction cosines 12 divided by 13 minus 3 by 13 minus 4 by 13, 4 by 13, 12 by 13, 3 by 13 and 3 by 13 minus 4 by 13, 12 by 13 are mutually perpendicular. We know the perpendicularity condition, dot product has to be 0. These are direction cosines. So, in terms of direction cosines, the condition is L1 L2 plus M1 M2 plus N1 N2 should be 0. Let us calculate for the first two lines. 12 times 4, 48 divided by 169 plus minus 3 times 12 minus 36 divided by 169 plus minus 4 times 3 is minus 12 divided by 169. LCM is 169. The numerator is 0. Therefore, the answer is 0. Let us take the first one as L1 line, the second one as L2 and the third one as line L3. So, this is for L1 and L2. Now, let us do for L2 and L3. So, dot product will be 4 times 3, 12 divided by 169. 12 times minus 4 is minus 48 divided by 169 plus 3 times 12 is 36 divided by 169. Here also the total is 0. The answer is 0. Now let us calculate for L1 and L3. 12 times 3, 36 divided by 169 plus 12 by 169 and minus 48 divided by 169. 0 divided by 169? The answer is 0. Therefore, the lines are mutually perpendicular. Question number 2. Show that the line through the points 1, -1, 2, 3, 4, -2 is perpendicular to the line through the points 0, 3, 2 and 3, 5, 6. Let us take the first line as L1 and the second line as L2. And when 2 points are given, we know how to find the direction ratios. We subtract. Therefore, direction ratios of L1 are, we can do first point minus second point or second minus first. 3 minus 1 is 2. 4 minus of minus 1 is 5. Minus 2 is minus 4. Now, DRs of the second line. Second point minus first point we are doing. 3 minus 0, 3. 5 minus 3 is 2. 6 minus 2 is 4. And the perpendicularity condition for two lines is A1, A2 plus B1, B2 plus C1, C2 should be 0. Let us multiply the corresponding direction ratios. 2 3s are 6 plus 5 2s are 10 minus 16 and the answer is 0. Therefore, the lines are perpendicular. Question number 3. Show that the line through the points 4, 7, 8, 2, 3, 4 is parallel to the line through the points -1, -2, 1 and 1, 2, 5. Let us take the first one as L1 line and second one as L2 line. Let us calculate the direction ratios of L1. We can do first point minus second point or second minus first. We are doing second minus first. 2 minus 4 is minus 2. 3 minus 7 minus 4. 4 minus 8 is minus 4. Direction ratios of L2. We will do second point minus first point. 1 minus of minus 1 plus 2. 2 minus of minus 2 plus 2, 4. 5 minus 1 is 4. We have to check whether they are parallel or not. So, proportionality we will check. All three ratios are same. Therefore, the lines are parallel. Question number 4. Find the equation of the line which passes through the point 1, 2, 3 and is parallel to the vector 3i plus 2j minus 2k. Let the position vector of the given point be vector A, which is I plus 2j plus 3k. And the parallel vector, we will take it as vector B, which is 3i plus 2j minus 2k. And we know the vector equation of a straight line passing through a point and parallel to a vector, which is vector r is equal to vector A plus lambda times vector B. Let us substitute I plus 2j plus 3k plus lambda times 3i plus 2j minus 2k. Or we can write the Cartesian equation because it is not mentioned in the question which equation is the required one. Question number 5. Find the equation of the line in vector and in Cartesian form that passes through the point with the position vector. We will take this as vector A, 2i minus j plus 4k, and is in the direction of, we will take this as vector B, I plus 2j minus k. The vector equation of a line passing through a point and parallel to a given vector is vector r is equal to vector a plus lambda times vector b. Let us substitute. Therefore, vector r is equal to 2i minus j plus 4k plus lambda times b vector is I plus 2j minus k. In this question, we have to write Cartesian equation also. The formula is x minus x1 divided by a equal to y minus y1 divided by b equal to z minus z1 divided by c. The given point is the components of vector a, which are 2, minus 1, 4, x1, y1, z1. And ABCs are the components of vector b. Let us substitute in the equation. X minus 2 divided by 1 equal to y minus of minus 1 is plus 1 divided by 2 equal to z minus 4 divided by minus 1. Question number 6. Find the Cartesian equation of the line which passes through the point minus 2, 4, minus 5 and parallel to the line given by x plus 3 divided by 3 equal to y minus 4 divided by 5 equal to z plus 8 divided by 6. Let us consider two parallel lines L1 and L2. If two lines are parallel, we can use the same direction ratios. The direction ratios of the given parallel line are 3, 5 and 6. So, we will use the same direction ratios for the line which we are going to find. Let us write the Cartesian equation of this line. X minus x1 divided by a equal to y minus y1 divided by b equal to z minus z1 divided by c. x1, y1, z1 is the given point. And ABCs are the direction ratios of the line. Let us substitute. X minus of minus 2 plus 2 divided by 3 equal to y minus 4 divided by 5 equal to z minus of minus 5 plus 5 divided by 6. Look at the denominators. They are same. Because direction ratios are same, they are parallel. Question number 7. The Cartesian equation of a line is x minus 5 divided by 3 equal to y plus 4 divided by 7 equal to z minus 6 divided by 2. Write its vector form. From the equation of the line, we can get the point on the line from the numerator. The point on the line is 5, minus 4 and 6. And from the denominators 3, 7, 2, we get the direction ratios of the line. Let us write the vector equation of the line. Vector r is equal to vector a plus lambda times vector b, where vector a is the point on the line and vector b is the parallel vector. Let us substitute 5i minus 4j plus 6k plus lambda times b vector is 3, 7, 2, 3i plus 7j plus 2k. So, if the equation of a line is given in Cartesian form, easily we can change it to vector form. Similarly, if it is given in vector form, easily we can write it in Cartesian form. Question number 8. Find the vector and the Cartesian equations of the lines that passes through the origin and 5, minus 2, 3. 2 points are given, so we will use 2-point form of a straight line. The equation is vector r is equal to vector a plus lambda times vector b minus vector a. A and b both are points on the straight line. We can interchange a and b. Let us substitute. Plus lambda times b minus a, second point minus first point, 5i minus 2j plus 3k. Therefore, the vector equation is vector r is equal to lambda times 5i minus 2j plus 3k. And we have to write the Cartesian equation also. Let us use 2-point form. X minus x1 by x2 minus x1 equal to y minus y1 divided by y2 minus y1 equal to z minus z1 divided by z2 minus z1. We will take the origin as x1 y1 z1 and the second point 5 minus 2 3 as x2 y2 z2. Let us substitute in the equation. X minus 0 divided by 5 minus 0, which is 5, equal to y minus 0 is y divided by minus 2 equal to z minus 0, which is z divided by 3. This is the Cartesian equation of the line. Question number 9. Find the vector and the Cartesian equations of the line that passes through the points 3 minus 2 minus 5 and 3 minus 2 6. 2 points are given. It is similar to the 8th question. We will use 2-point form. Let us write the vector form. Vector r is equal to vector a plus lambda times vector b minus vector a. We will take the first point as vector a and second one as vector b. Let us substitute 3i minus 2j minus 5k plus lambda times b minus a. 3 minus 3, 0, minus 2 minus of minus 2, that is also 0, 6 minus of minus 5 plus 5, 11 k cap. This is the vector equation of the straight line. We have to write the Cartesian equation also. X minus x1 divided by x2 minus x1 equal to y minus y1 divided by y2 minus y1 equal to z minus z1 divided by z2 minus z1. We will take the first point as x1 y1 z1 and the second one as x2 y2 z2. Let us substitute. X minus 3 divided by 3 minus 3 is 0 equal to y minus of minus 2 plus 2 divided by 0 equal to z minus of minus 5 plus 5 divided by 11. This is the Cartesian equation of that straight line. Question number 10. Find the angle between the following pairs of lines. The first line is vector r is equal to 2i minus 5j plus k plus lambda times 3i plus 2j plus 6k. And the second line is vector r is equal to 7i minus 6k plus mu times I plus 2j plus 2k. Angle between two lines is same as angle between the parallel vectors b1 and b2. Therefore, cos theta formula is absolute value of vector b1 dot vector b2 divided by magnitude of b1 vector into magnitude of b2 vector. From the first line this is b1 vector and from the second line this is b2 vector. Let us find the scalar product. Multiply the corresponding components and add 3 plus 2 2s are 4 plus 6 2s are 12 divided by magnitude of B1 is root of 9 plus 4 plus 36 into magnitude of B2 vector root of 1 plus 4 plus 4, which is equal to 19 divided by root of 49 times root 9, which is equal to 19 divided by 7 times 3, which is 19 divided by 21. Therefore, theta is equal to cos inverse of 19 by 21. Second subdivision. The first line equation is vector r is equal to 3i plus j minus 2k plus lambda times I minus j minus 2k. And second line equation, vector r is equal to 2i minus j minus 56k plus mu times 3i minus 5j minus 4k. It is a similar question. This is vector b1 and this is vector b2. Let us write cos theta formula. Cos theta is equal to absolute value of vector b1 dot vector b2 divided by magnitude of vector b1 times magnitude of vector b2. We will get the acute angle between these two lines because of the absolute value sign, which is equal to absolute value of 3 plus 5 plus 8 divided by magnitude of b1 is root of 1 plus 1 plus 4 into magnitude of the second vector root of 9 plus 25 plus 16, which is equal to 16 divided by root 6 times root 50 equal to 16 divided by root of 300. Root 300 can be written as 10 times root 3. Let us simplify. Therefore, theta is equal to cos inverse of 8 divided by 5 times root 3. Question number 11. Find the angle between the following pairs of lines. The first subdivision, x minus 2 divided by 2 is equal to y minus 1 divided by 5 is equal to z plus 3 divided by minus 3 and x plus 2 divided by minus 1 equal to y minus 4 divided by 8 is equal to z minus 5 divided by 4. Angle between two lines is same as angle between vector b1 and vector b2. These line equations are already in the standard form. Let us write vector b1 from the first line. The denominators are the direction ratios of b1. The vector is 2i plus 5j minus 3k. And vector b2 of the second line is minus I plus 8j and plus 4k. Angle between two lines formula, cos theta is equal to vector b1 dot vector b2 divided by magnitude of b1 times magnitude of b2, and we have absolute value sign so that we will get the acute angle between the two lines. So dot product of b1 and b2, multiply the corresponding components and add minus 2 plus 5 8s are 40 minus 3 4s are 12. Absolute value of this divided by magnitude of b1 vector root of 2 square plus 5 square plus minus 3 the whole square times root of minus 1 square plus 8 square plus 4 square, which is equal to 40 minus 14, 26 divided by root of 38 times root of 81, which is equal to 26 divided by 9 times root of 38. Therefore, theta is equal to cos inverse of 26 divided by 9 times root of 38. The second subdivision, same type of question. The equations are x divided by 2 is equal to y divided by 2 is equal to z divided by 1, and the second equation is x minus 5 divided by 4 equal to y minus 2 divided by 1 is equal to z minus 3 divided by 8. B1 vector of the first line is 2i plus 2j plus k, and B2 vector of the second line 4i plus j plus 8k. In this question also the equations are in the standard form. If line equations are given, check whether they are in the standard form before using them. Cos theta formula is absolute value of vector b1 dot vector b2 divided by magnitude of b1 times magnitude of b2. Let us find the scalar product. No ijk should be written in the scalar product. 2 4s are 8 plus 2 plus 8 divided by magnitude of the first vector root of 2 square plus 2 square plus 1 square times root of 4 square plus 1 square plus 8 square, which is equal to 18 divided by square root of 9 times square root of 81. 18 divided by 3 times 9, 2 divided by 3. Therefore, theta is cos inverse of 2 divided by 3. Question number 12. Find the values of p so that the lines 1 minus x divided by 3 equal to 7y minus 14 divided by 2p equal to z minus 3 divided by 2, and 7 minus 7x divided by 3p equal to y minus 5 divided by 1 equal to 6 minus z by 5 are at right angles. These two given equations are not in the standard form. What do you mean by the standard form of a straight line? The coefficients of x, y, z should be plus 1. Let us change them to standard form. X minus 1 divided by minus 3. Whatever you do to the numerator, do the same changes to the denominator also. I have changed the sign in both numerator and denominator. Equal to, let us divide by 7. Y minus 2 divided by 2p divided by 7. Don't forget to divide the denominator also. This is in the correct form. Z minus 3 divided by 2. And let us change the second line. We have to divide by minus 7. Divide both numerator and denominator. So x minus 1 divided by minus 3p divided by 7 equal to, this is in the correct form, y minus 5 divided by 1 equal to, here we have to change the sign. And don't forget to change the sign in the denominator. So z minus 6 divided by minus 5. Now the denominators are b1 and b2 vectors. Vector b1 is minus 3i cap plus 2p by 7j cap plus 2k cap. And b2 vector is minus 3p by 7 I cap plus j cap minus 5k cap. The lines are perpendicular to each other. So b1 vector is perpendicular to b2. Therefore, dot product has to be 0. Let us find the dot product. Multiply the corresponding components. No ijk in the dot product. Minus 3 times 3p by minus 7 plus 2p by 7 into 1 plus 2 times minus 5, which is minus 10, equal to 0. Cancel minus signs. 9p by 7 plus 2p by 7. Let us take minus 10 to the other side plus 10. 11p by 7 is equal to 10. Therefore, p is equal to 70 divided by 11. Question number 13. Show that the lines x minus 5 divided by 7 equal to y plus 2 divided by minus 5 equal to z divided by 1 and x divided by 1 equal to y divided by 2 equal to z divided by 3 are perpendicular to each other. These equations are already in the standard form. We will write b1 vector, the denominator 7i minus 5j plus k, and b2 vector from the second line I plus 2j plus 3k. The perpendicularity condition is vector b1 dot vector b2 should be 0. Let us check vector b1 dot vector b2. 7 into 1 is 7 minus 5 into 2 is 10 plus 1 into 3 is 3. The answer is 0. That means the lines are perpendicular to each other. Question number 14. Find the shortest distance between the lines. Vector r is equal to I plus 2j plus k plus lambda times I minus j plus k, and vector r is equal to 2i minus j minus k plus mu times 2i plus j plus 2k. From these equations, we get the point vectors vector a1 and from the second line vector a2. Similarly, we get vector b1 from the first line and vector b2 from the second line. The shortest distance formula is vector b1 cross vector b2 dot vector a2 minus vector a1 under absolute value sign, because distance has to be a positive quantity, divided by magnitude of vector b1 cross vector b2. Let us find vector b1 cross vector b2, which can be written as a determinant I, j, k, the components of vector b1, 1, minus 1, 1, and then components of b2 vector 2, 1, 2. Let us find the cross product. I times minus 2 minus 1, which is minus 3, minus j times 2 minus 2, 0, plus k times 1 plus 2, which is 3, which is equal to minus 3i plus 3k. Let us find a2 minus a1. Vector a2 is 2i minus j minus k and minus of a1 vector is I plus 2j plus k. Let us subtract. 2 minus 1 is 1i, minus 1 minus 2 is minus 3j and minus 2k. Let us substitute in the formula. The numerator is the dot product of these two vectors. Let us multiply the corresponding components. minus 3 and j component is 0 and minus 6 divided by magnitude of vector b1 cross vector b2 is root of 9 plus 9 equal to 9 divided by root of 2 times 9, which is equal to 9 divided by 3 root 2. Let us cancel 3. The answer is 3 divided by root 2. Let us rationalize the denominator. Multiply both numerator and denominator by root 2. 3 root 2 divided by 2 units. This is the shortest distance between the two lines. Question number 15. Find the shortest distance between the lines x plus 1 divided by 7 equal to y plus 1 divided by minus 6 equal to z plus 1 divided by 1 and x minus 3 divided by 1 equal to y minus 5 divided by minus 2 equal to z minus 7 divided by 1. Here the equations are in Cartesian form. Let us write b1 vector from the first line. 7i minus 6j plus k. Then from the second line, vector b2 is 1i minus 2j plus k. The shortest distance formula is vector b1 cross vector b2 dot vector a2 minus vector a1. We have absolute value sign to make the distance positive divided by magnitude of vector b1 cross vector b2. Let us write vector a1 and vector a2 from the equations from the numerators. Be careful with the signs. The standard form has minus sign in between. Let us write vector a1, which is equal to minus 1i minus 1j and minus 1k, and vector a2 is equal to 3i plus 5j plus 7k. Let us find vector a2 minus vector a1. 3 minus of minus 1 plus 1 4i plus 5 minus of minus 1 plus 1 6j plus 8k. Let us find b1 cross b2. Write it as a determinant. I, j, k. b1 vector 7 minus 6 1. Then components of b2 1 minus 2 1. Let us expand this determinant. I cap into minus 6 plus 2, which is minus 4, minus j times 7 minus 1 is 6 plus k times minus 14 plus 6 minus 8. Therefore, we get minus 4i minus 6j minus 8k. Therefore, the shortest distance becomes, we have to find the dot product of these two vectors. Multiply the corresponding components and add. Minus 16 minus 36 minus 64. Absolute value sign is there in the numerator, divided by magnitude of b1 cross b2 is root of 16 plus 36 plus 64. The total is 116 divided by root of 116, which is equal to root of 116. Let us do prime factorization of 116. Which is equal to 2 times root 29 units. Question number 16, again shortest distance question. Find the shortest distance between the lines whose vector equations are vector r is equal to I plus 2j plus 3k plus lambda times I minus 3j plus 2k. And the second line is vector r is equal to 4i plus 5j plus 6k plus mu times 2i plus 3j plus k. From the first line, this is vector a1, and from the second line, this is vector a2 and vector b1 and vector b2. Vector a1 is I plus 2j plus 3k, and vector a2 is 4i plus 5j plus 6k. Let us find vector a2 minus vector a1, which is 3i plus 3j plus 3k. And we need to calculate vector b1 cross vector b2. Write it as a determinant I, j, k. Components of vector b1, 1, minus 3 and 2. Then b2 vector 2, 3, 1. Let us expand. I into minus 3 minus 6, which is minus 9, minus j cap into 1 minus 4, which is minus 3, plus k cap into 3 plus 6, which is 9. Therefore, we get minus 9i plus 3j plus 9k. The shortest distance formula is D is equal to absolute value of b1 cross b2 dot vector a2 minus vector a1 divided by magnitude of vector b1 cross vector b2. Let us find the dot product. Multiply the corresponding components and add. 3 into minus 9 is minus 27, plus 3 3s are 9, plus 27. Absolute value sign is there. Divided by magnitude of b1 cross b2 is root of 81 plus 9 plus 81, which is equal to 9 divided by root of 171. Let us do prime factorization. Divided by 3, 57. Again by 3, we get 19, which is equal to 9 divided by 3 root 19. Therefore, it is 3 divided by root 19 units. Question number 17. It is an important question. Find the shortest distance between the lines whose vector equations are vector r is equal to 1 minus t I cap plus t minus 2 j cap plus 3 minus 2 t k cap, and vector r is equal to s plus 1 into I cap plus 2s minus 1 j cap minus of 2s plus 1 k cap. The vector equation of a line is in the form vector r is equal to vector a plus lambda times vector b. These are not in the standard form. In the first equation, the scalar is t. In the second, it is s. Let us open the brackets and write vector r is equal to I minus ti plus tj minus 2j plus 3k minus 2tk. Let us rearrange the terms. Without t terms we will write, and then with t terms. I minus 2j plus 3k plus t times minus 1i plus 1j minus 2k. Similarly, we will write the second equation. Vector r is equal to, open the brackets, si plus 1i plus 2sj minus j minus 2sk minus k. Now let us write all terms without s and then with s. I cap minus j cap minus k cap plus s times I cap plus 2j cap and minus 2k cap. We have written these line equations in the standard form. Vector a1 from the first line equation is I minus 2j plus 3k, and vector a2 from the second line is I cap minus j cap minus k cap. Let us find vector a2 minus vector a1. 0 I cap, minus 1 minus of minus 2 plus 2 will become plus j cap and minus 4k cap. b1 vector from the first line is minus I plus j minus 2k, and vector b2 from the second line equation is I cap plus 2j cap minus 2k cap. Let us find vector b1 cross vector b2. Determinant I, j, k, components of b1 vector minus 1, 1, minus 2, and components of the second vector 1, 2, minus 2. Let us expand. I cap times minus 2 plus 4, 2i minus j cap into 2 plus 2, 4 plus k cap into minus 2 minus 1 minus 3. Therefore, b1 cross b2 is 2 I cap minus 4 j cap minus 3 k cap. Let us write the shortest distance formula. Vector b1 cross vector b2 dot vector a2 minus vector a1 under absolute value sign divided by magnitude of b1 cross b2. Let us find the dot product of a2 minus a1 and b1 cross b2. Let us multiply the corresponding components and write I component is 0, minus 4 plus 12 under absolute value sign divided by root of magnitude is 4 plus 16 plus 9, which is equal to 8 divided by root 29 units.